Let me know if you can see my screen. I guess no, right? Right now? No, right? Okay, wait. Uh, okay. So, distributed data. We talk about distributed data, we never think about it, okay? We talk in a sense, as in whenever we touch any, website or stuff, any app, any website which is, have crossed 10,000 users mark, daily active users of, more than one 100,000. So they have to, distribute their data, otherwise they will probably somewhere down the line, we feel will feel lag somewhere, and they will fall down on the part of scalability. So scalability, maintainability, reliability, and these all are, base of any system, okay? So whenever we talk about computing, apps, web apps, data, so when people want to scale, right, they have to keep three things in mind, okay? Maintainability, scalability, and reliability. Your code should be reliable, your code should be maintainable, and you can easily scale. And for this, the best way is to think around the available sources which are there to help you, in a sense that, okay, maintainability I have to approach this way, reliability I have to approach this way, scalability I have to approach a different way. So maintainability we'll talk separately some other day, but scalability is one thing. When it comes, right, you have to suddenly, you are an owner of a website and you suddenly have a higher loads, okay, and then you start thinking, I am facing lags. The best example is your PF site, and other any other government websites you go and you just see what happens there, okay? You'll feel a lot of lag. There are billion of people, trying to log in into PF website, and it's a tremendous failure on, this part. Same happened with, our ITR website like 2 to 3 years ago, when Infosys was under the lens, how they are working, and how can this happen eventually. This should actually not be happening because it's managed by a private company. But when scaling is difficult, right, it creates a lot of complex issues, and people never understand it from that perspective, okay? So scaling is important. So when volume grows, you have to scale, and to scale, there is only one way which is best, which is distribute your data. Because at the end, whether it's your app, whether it's your data warehouse, whether it's, streaming, if your data is not distributed, you will not be able to scale properly, okay? So scaling means distribute your data. So what distribute means here? It could mean that either you have one machine, okay, you increase RAM, you increase disk, you increase the nodes, or you have separate machines. In that specific machines, you increase RAM, storage, cores, okay? So there are several ways to distribute the data and have, compute nodes to, cater to those requests. But whenever I am in this topic, you should always keep asking yourself, how would this be happening? Network connectivity is very important. Network lags, maintaining network lags is very important. One data available on another system at the right moment is very important. The user should not feel, that they are seeing the lag, or they are seeing the stale data or incorrect data, even if, the data is distributed. So scaling is the first thing we'll talk about here, and then inside scaling, when we discuss, there are n number of topics, to cover. So how to scale specifically, okay? So when you are discussing about scaling, there are two ways specifically, and we'll discuss that. First is vertical scaling and second is horizontal scaling. So this will be asked in any interview question, like how BigQuery actually maintains its data, or how internals of BigQuery works. So if you want to read, there is a blog by Google on capacitor. You can read that for the storage part. And then Jupyter, I guess there is compute. So there are four layers to it. So you can read about that. Separate compute, separate storage, and everything. Network also is built. So they have separate names to it. I cannot recall. I just recall, I guess, Jupyter and capacitor. Okay. So we'll study from the perspective of web apps and distributed data warehouses both. So you can scale vertically. First of all, what is vertical scaling? Which means you had a small uh, computer. Okay, then you, on the same computer, you had an option of adding more RAM and adding more cores. Okay, I'm not sure if you have any time bought a laptop by yourself and went to the vendor and asked that, okay, I want specifically to be enhancing this particular laptop to a specific load. Okay, so let's say down the line you think that 16 GB RAM would not be sufficient, so give me one more slot. Later I will decide and put one more 16 GB RAM on it. And cores, I am sure cores are already decided right now in your laptops. There is no option for cores, but yeah, for in your desktops and stuff you can add the cores also. You can change that. So just think from a perspective of your one single machine, and you start adding stuff on that particular single machine. Now particular single machine means single operating system and shared memory, which means the memory is shared. Okay, you are increasing the cores, but memory is shared. Okay, whatever is there, every core will share that memory. You went from 16 to 32, but the cores will share that memory. Okay, they have to share that memory. There is no specific partitioning of memory. So single operating system, single memory, multiple cores, but you increase the size. Okay, so there are cons to it. you know there is no specific guarantee that when scale volume grows, you will not bottleneck yourself. Okay, so there are no justifications to this. So you have to think from this perspective that just increasing on a single machine will not help you. So this is vertical scaling. So why it is vertical? You just increasing on top of same machine or a rack. Okay, on a same rack you are increasing the size of memory, you are increasing the number of cores on same. So operating system is still one. Okay, they don't have separate operating systems. So this should be understood from the shared memory perspective and single operating system. Another problem, there is no replication, and fault tolerant gets down because location where you are storing the data is only one machine. Okay, so all, so let's say you have users from USA, you have users from Europe, all the data in single place. You can't go and keep your data in Europe. It's a single machine we are talking about here. This is a very basic architecture. Then coming to vertical scaling, shared disk approach. Okay, now the disk, we are sharing the disk, not the RAM, but we are sharing the disk. So every node has its own CPU and RAM, but we are sharing the disk. Okay, now when we talk about disk, it is your actual, when we talk about disk, we should think from the perspective of actual databases. When we think from the databases, it is your, what databases? Maybe it is uh, OLTP. Maybe we can talk about Postgres. We can talk about SQL server. We can talk about MySQL. Uh, any other Oracle. So they save their data in disk. Okay, so whenever you query select star from, they actually have to go, and there are some data structures on top of it which helps you to fetch the data faster, whether it will be index or any other benefit, execution plans and stuff. But the data eventually stored on the disk. Now in this approach we have a long disk. Okay, an array of disk, we increase the disk size. Okay, so pros are good, that okay, you still get strong consistency. uh, so consistency we have already discussed in last uh, lecture, that what consistency was, you know and then acid on top of it. So atomicity, you know consistency, isolation, durability. Because it's a single disk, it is manageable. You can add more computes on top of it. You can just keep on sharing. So growing faster is easier. Okay, but what is the problem? Since we learned in the last lecture, whenever we, the databases, OLTP systems, they query, okay, we are talking only about relational databases here. Okay, we'll not talk about non-relational. Non-relational is totally different stuff. Okay, so we'll talk about relational stuff. And to be honest, most of the industry right now still uses OLTP systems on non sorry, relational, which is your Postgres and MySQL, because they are open sourced. So you should think from that perspective first, and you will eventually work on those systems first to migrate your warehouses to BigQuery. The problem is, whenever we query the data from a shared disk, okay, there will be a locking mechanism in picture. What is lock? We already discussed in last lecture that whenever we query, there are two types of locks. Okay, there is a shared lock. There are four types, but there is a combination. Okay, shared lock, uh, there is exclusive lock, there is shared exclusive, there is exclusive shared. So shared lock means whenever you read the data, your row will be given a lock. Okay, that somebody is reading it with a transaction. Then whenever somebody is writing it, it is a X. Now imagine if it's a shared disk, which means all the nodes, with their own CPU and RAM, but they still target the shared disk, which means your concurrency will go down. There will be locking mechanism which will lock the rows. Okay, you will still be seeing the data which is locked by someone else, so there will be a lag. Okay, until and unless the lock is released, you'll not see the data. And single point of failure, which means if this array of disk fails, okay, uh, there is a problem. So the problem is, the disk should be fault tolerant. There should be an approach to it, so you have to manage disk separately. But the whole thing is, it depends upon the type of load you have. So neither of these approaches are right or wrong. It depends upon the type of load you have. If you have multiple users who are only reading your stuff, then shared disk approach still works, because they just want to read more. Okay, okay. Otherwise you'll have to think about, okay, there is a more write happening, everybody is writing, and then there are users who are reading the same data, then shared disk approach will create lags. Okay, it is best from the perspective of reads, but maybe there will be a lag on write, when you write and then read it. So the two approaches on vertical we know, shared memory and shared disk. Okay. Now we'll jump to another, which is the third one, which is actually horizontal. So this is what is happening in all our MPPs. Okay. Massive parallel processing. So our big queries and maybe Azure Synapse, Redshift, they all work on scaling to higher loads with sharing nothing, horizontal scaling, which means there is nothing shared. Okay, nothing is shared. Disk is separate, RAM is separate, CPU is separate. You increase more nodes, you get more benefit. Okay, but think about it, if nothing is shared, the problem is, what will happen if one type of data we have pushed onto one disk, and it has to be available on the second disk also at the same moment, because that means high availability. you know People may not read from same node, people will be reading from separate node. There will be a master slave approach, or there will be leader follower approach. So in this type of scenario, there is lot of scopes to scale, but it becomes very complex to handle. Okay, each machine, or a virtual machine, has its own database systems. Okay, they can have their own database system. On one you can run Postgres, on another you can run Oracle, on another you can run MySQL, if you want to grow. So then you will make sure that, okay, the databases are same, but my data is same. Okay, orders, if it is in Oracle, it has to be the same orders replicated on MySQL, replicated same on Postgres. Or you will think, okay, I'll have Oracle everywhere. Okay, if you want to keep the databases constant. Now you may also think that if I go with MySQL or Postgres or Oracle, there is a version constraint. Okay, so all the versions should be same, because when you start replicating the data from one node to another, there will be a problem. So the part what I'm trying to say is databases are separate, disk is separate, everything is good, working good. But the problem here comes is, how will you make sure that all the data for all the customers is eventually actually distributed around all the nodes? Because in previous one, when we saw, it was shared disk, whatever you are putting in, it is seen by all the systems automatically, because there was acid in between. Okay, acid was helping us. If you see, there was strong consistency, shared disk, whatever data is written, whatever data is read, it is at a single place. In this also, it was shared memory, shared disk. As in, if memory is same, it's a single machine, it will be same disk also, but the size will vary. So in both these approaches, there was acid in place. Because of acid, everything was managed by the database itself. Now when we come to this particular stuff, every node will have their own acid. Okay, they will have their own acid approach, which will be atomic, consistency, isolation, durability. Whenever transaction completes, you will see the completed transaction atomicity. It will be isolated, it will be consistent, it will be durable. Whether it happened, it will be committed, not happened, it will be aborted. Okay, but think about from the perspective that node 1 knows that, okay, this transaction was committed, and it has to replicate or tell everyone other nodes that this has happened. Please keep a note of this. In a simple language, I'm explaining this. Okay, so this is the next topic, which will be replication. Why and how replication works, we'll discuss. But before that, I'll take a pause of maybe 2 minutes and try to understand that from you. If you actually understood, scaling actually can be done in various ways. Okay, vertical and horizontal. Vertical scaling is again divided into two parts. You can grow horizontally in two ways. You increase everything, keep the disk size same. Okay, and or you increase the disk size also, and have separate nodes on it. You are sharing disk. And third is nothing shared. Nothing is shared. You grow it this way. So any questions on these three, first of all? Then we'll jump into why replication and stuff. Okay, so it is understood, right, Vignesh, Vamsi? So if I take a topic of data proc, okay, data proc gives you master slave configuration, right? You have master and then you have slaves. And for every data proc node or machine type, you give a machine type. Okay, what will be the machine type? N14, N12, N18. So based on that, the RAM and stuff changes. Okay, for that, you can decide whether you want to give persistent disk on it or not. So you are aware of this topic, that data proc gives this master slave configuration via shared nothing approach, because we all are from GCP, that we. Hmm. Hmm. Correct. So that is what is shared nothing approach. But whenever you go into this into retail, there will be a lot of complexities, because each node uses its own CPU and RAM. They will not be aware of what is happening on the another node. Now I am saying, now they will not be aware, but eventually we'll talk about replication. Then they will get to know. So whenever you think from the perspective of how stuff would be happening, there would be some tool, okay, helping it. What is that tool? Maybe that tool is eventually given by the database itself. Like Oracle gives replication benefits, MySQL gives replication. uh, every other database has replication way of giving a replication to it. If you go into studying about replication tools, so your task today would be probably to just read about replication tools in the market. And what are their benefits? Like Postgres has some, MySQL has some inbuilt, Oracle has its own, SQL Server has its own. So in previous lecture we already learned that we can't get away from OLTPs, and if we can't get away from OLTPs, which, and we have to scale, which means we have to replicate also. Okay, if we don't replicate, data would be stale and people would be reading the incorrect data somewhere or writing the incorrect data somewhere. Just a minute. Okay, so what is replication? So replication means actually that you have data in one place, you start copying it to other places also. Okay, replicate means actually the same copy of data. Okay, why we need same copy of data? Why we need same copy of data is that there is a requirement, first of all, that you have to reduce the latency. Okay, then there is a requirement that you have to scale out. Okay, okay, then there is a requirement that your system should not be failing at one node, that only, which is your primary node. So close to your users, and even if there is a failure, you should continue to read and write. You should scale out the number of machine and serve the read queries. So eventually everyone wants their users to be happy. I am not happy using EPFO website because they are not managing replication in a better way. Okay, they are not managing distributed data in a better way. uh, Same issues you might feel with some other applications. So if you think that there is a massive volume of this, think from a perspective of, are they actually managing data, distributed data, effectively? If you are feeling the lag, if you are unhappy, which means there is some gap between their front end and distributed data. Okay, so replica can be read replica also, there can be write replicas also. Okay, so when you go to cloud SQL, you will start reading, you will see that you can add MySQL, you can add Postgres on cloud SQL, Google Cloud SQL. So when Google Cloud SQL provides inbuilt uh, Postgres, SQL Server, MySQL, they, then it automatically comes with the replication features built in. So which means there can be read replicas, there can be write replicas, but basically copy of data means we are reading on a basis wherein we are increasing the throughput to read faster. Okay, so you have one place which is affecting the data, and then all places which should be transposed, or we should be aware of what changes happen on the primary data, should be connected internally somehow. And this is not via code or something, this is internally done via code. You don't have to code it, so replication features are given in. So you have to think from that perspective that you don't have to do it, but you have to write some mechanism to run that replication effectively. Okay, so there are tools built in. On top of that, you build an abstractions and stuff that replication happens effectively. So replication is clear, why we replicate and what it is. Okay, so you need to understand one more thing. There is replication and there is also partitioning. So partitioning we'll talk about later. Why? Because partitioning comes into picture when on a same machine you cannot keep you know huge volume of data. So if you are keeping small enough data which can sit on your machine, okay, then you replicate. If you have a huge volume of data, then only replication will not work. You have to partition, then replicate, and maybe shard also sometime later. Okay, so there are three main pointers, which is replication, partitioning, and sharding, but all of this work in tandem. Right now we are studying replication because we are assuming that our data is small enough to sit on one machine. Okay, all good. We'll keep this in mind. Okay, else we have to partition it. Now, when to replicate? Best way is your data doesn't changes over time. If your data keeps changing over time, let's say for example you went to Amazon, you placed an order, transaction is completed, you are just seeing that okay, my order is placed, I go to the order screen, I am seeing okay, now this order will be delivered by this date. Now this data will change. What will change? Delivery track will change. Okay, will you keep that on a replicated stuff? If yes, then you will have to manage it that way, that okay, there will be a lot of changes happening on the deliveries track, that it, there will be a punch in somewhere happening. Okay, before that out of delivery somebody tagged in from the warehouse. Okay, it went to Haryana, then to Delhi, then to Mumbai. A lot of tags are happening to your particular order, and then it's a lot of changes that are happening. Maybe they are managing it well and you are still seeing it, but the best approach to read is to replicate the data which is not changing over time, which is easier to approach, right? The data which is just sitting and you people just want to read it effectively. Okay, you can replicate it. Another thing is replication. In replication there is a difficulty which is of handling changes. So maybe Amazon is replicating that stuff because it's a huge size, but they are effectively handling the change mechanism, okay, to replicate that data. The change mechanism we'll see, which means there is a write happening to the data, there is an update happening to the same order when it is punched into a lot of places. There are a lot of scanning happening at every place, and then it is moving and moving and moving, and you are seeing that all history track, which means they are still managing at a place wherein they are handling these changes with a very effective way. But in a nutshell, when to replicate is, when your data doesn't changes over time. Then all distributed databases, they have to follow one of the three approaches to replicate. Then on the right side, if you see, I have given, best tools right now in the market for 2026, which are good to, replicate your data. But they all might be following some of the three ways, which is single leader, multi leader, or leaderless replication. We'll discuss this in detail, but I'll talk about the tools that are available in market. So real time SQL databases replication with low setup effort, blade pipe is there. Okay, then it, when we talk about OLTP and stuff on relational, we'll more talk about the change data capture, which is CDC. If you are not aware of CDC, just hold your thoughts for a moment. uh, I'll not discuss in detail, but CDC is, your name changed, and any other stuff changed, and you want to see it right away. uh, the best is, if you have used any app which delivers 7 a.m. delivery and you place the order day before, so you can update it till 10 p.m. If you have used big basket, maybe the moment you do an update, there is a stuff happening on your system which is on your mobile, but it is being replicated somewhere. Okay, okay, so all that changes go from your one of the replication to another machine, which is big basket servers, and then CDC comes into picture, that you have changed the quantity, you have paused the subscription, something you have done. So then the system would say that okay, something has changed. Okay, you are capturing that change, and then at the end somebody would be consuming that data to actually deliver what at what quantity. So CDC you can read about. So there is a lot of talk about CDC. When you grow, you will be asked more question on CDC and how to replicate data because of CDC. Okay, for Go Oracle, there is Oracle Gate. AWS had its own AWS DMS. Google has its data stream, so you can manage data stream. You can connect to any. RDBMS and get the data out of it at the moment it happened. The write happened and you are reading that write via data stream, and you can put it into BigQuery that way. That fast it is. Whatever orders happened, you are just using data stream, putting it to BigQuery. Debezium, best for Kafka. 5tran, fully managed. Airbyte is there. Replicate, stream. All these are replication tools. So any question on this? Why replication? Why we are replicating, and the tools, and then we'll see single leader, multi leader, and leaderless replication. So one of the three would be followed somewhere, and then in each there is synchronous, asynchronous, various types of replication. But yeah, any questions on this? So yes, so right replicas will be the last topic. You know, there will be multi leaders where there will be multiple write replicas. So from single leader you can understand that there is only one place where the write happens, and all those writes will replicate to your other read replicas. But then if you have various places wherein uh, you are getting orders from, and you cannot keep one data center to be as a specific node of failure, then you create more data centers like in India, Europe, USA, and then you have multiple leaders there. That means multi-leader replication. So we'll talk about that also. So write replicas still possible. People do it. They have to do it if their application grow. Answered, I guess. Okay. Mhm. 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 So your question is on CDC and data stream, whether why they are not using it. So it most of the time it depends upon the use case also. So CDC and CDC actually is only for capturing the change. If requirement doesn't wants to you to capture the change and show it somewhere, people will not invest in it. So it is also a costly thing that you are showing the real time events. You will have to use either Kafka PubSub to capture the events via CDC, and then show it on your either dashboard directly or BigQuery somewhere. But CDC is always in picture, but people don't implement it. It's always a decision whether they want to see 1 day stale data or they want to see 2 minutes stale data. Okay, so it depends. And what type of Hmm. Near real time, yes, correct. So they will think, okay, I can do it in another way. I don't have my requirements that way. If I talk about fraud detection, okay, fraud detection is one case where you want to actually know what happened at the moment when the person did a transaction of 1 lakh on his credit card. Was it the person doing it, or was it uh, malware or something happened on the website, which was automated way? So that event happened at the right moment. It went to your OLTP systems. If OLTP system is queried after 24 hours, how can you detect a fraud? Right, you will not be able to detect a fraud. You have to report it right away. If I have a credit card, and the moment I use it for more than 50,000, I immediately get a call, like within 2 seconds. Okay, within 2 seconds I get a call from my ICICI bank, which says, okay, whether this transaction was done by you. If yes, just press 1. Which means CDC happened somewhere, right? Your transaction was done, CDC pushed the data that captured the change and pushed it to some streaming, and then you are getting a call. So it's all automated. How? We need to think. It's distributed. There is CDC in picture, and there is another set of code which is written to call you. Got it. Okay. Jumping to uh, replication again. So there are some more pointers, which you need to buy hard, okay, whenever you think about replication. So each node that stores a copy is called a replica, which is one thing, okay. It will be write replica or read replica, we'll see further, but it is called a replica. But whenever you push the data to a replica, how do you ensure that data ends up on all the replicas? There may be hundreds of replicas. There will be network congestions. There will be network problem. There would be some faults happening. How will you make sure that it is available on all the replicas? Which is one problem, right? Every write that happens to a database needs to be processed. Every replica, every write, you and are understanding. Every write, an insert is a write, an update is a write. Okay, a put request from an API is a write. A post request from an API is a write. Can you imagine what would be happening at Flipkart, Blinkit, Amazon, other website, maybe Swiggy, and another stuff, Zepto? What would be happening every single minute? That's how they give you the, every year they give that, you know, uh, benchmarks, that how much they process. So keep this in mind. Every write to a database needs to be processed by every replica. This line is the crux of replication. No batching here, okay? No batching. Every write to database needs to be processed by every replica. Okay. Maybe there is some stale data on others, okay, because there was a network congestion. So there are usually two ways to do it, which is synchronous, which means synchronous actually means that every node is in sync, which means I tell you, Vignesh, that keep 100 rupees. Okay. You tell Vamsi that Abhishek gave me 100 rupees. Until and unless you tell Vamsi and Vamsi tells me back that Abhishek, you had given 100 rupees to Vignesh, I will be satisfied because my source of truth is all of you. Okay. That all of you should know that I have given you 100 rupees. So I gave you 100 rupees, you are telling Vamsi and Vamsi telling me back. So synchronous means all of us are in sync that okay, I gave Vignesh 100 rupees. Okay. Now this is very plain example. Now think about from the perspective of e-commerce website. Order happened, order was placed, now it has to be replicated to all the systems, all the replicas, all the data centers, all over the world, geolocated for Amazon base, Amazon sized application. What would happen if there is a synchronous replication everywhere? There would be a lag until and unless I know, I will not tell the user that okay, your order has been placed. So because I am the leader, okay, where writes are happening right now, there is a single machine, okay, which is me, and I am not being aware about all the systems, until and unless they tell me that okay, the order has been placed, it has been replicated because that was the right. All the systems, all the machines are not aware. They're totally unaware. They're not aware of this. Till the moment there is a lag, let's say for a fraction of millisecond, there are 100, you multiply it by 100. Even if you get a lag of 3 seconds, you will leave that website. Okay. Today is the place wherein people want space, speed. Okay. With thousands of replicas, okay, with hundreds and thousands of replicas, even a millisecond of lag will cause a problem. So synchronous comes into picture, that all should know eventually, and finally the leader should get an acknowledgement that okay, I will now tell the user that order has been placed. That's it. So do you think synchronous is actually the right way to do it? There is if and but here, but it depends. Okay. Then there is asynchronous. I did an order, it was placed on a leader, okay, leader database. It will tell to other replicas asynchronously. but it will tell the user that order has been placed, and you now can sit quietly and proceed with the application closer logout. This is still better. Okay, I don't have to wait for 100,000 replicas to be telling me. But think from a perspective that if I keep everything asynchronous, I placed an order, it was not replicated to other places, and this node failed. Okay, tomorrow I cannot read my own rights, which means I cannot read my own order. Your order is vanished because one of the node which I was having the order history, order database, everything that is died because of asynchronous replication. There was a network issue, nothing got replicated, your data is vanished. If you are thinking from a perspective nothing will go wrong, it's okay. Okay, but you have to think from a perspective, if there is a even a laptop, it needs some maintenance, it needs some updates. If you are not doing updates, it is fine. If you are using pirated version, it is fine. But machines which are working on the place which are actually for your Amazon or Flipkart or Blinkit, they need regular patching, they need a downtime. So assume from that perspective your leader, which is your place where the writes will happen, it is down because of patching. There would be another write replica, right? It has to know. So asynchronous application and synchronous application should work in tandem. They should know, they should work in a hybrid mode. Okay, so there is a trade-off, that you can use synchronous, you can use asynchronous, and how to handle the failed replicas. Okay, so this is the main part wherein we'll jump in the next session, wherein we'll discuss about synchronous, asynchronous, and how to handle the failed replicas. But I would like to pause here and uh, just show you a brief about leader and followers, so that we can continue on the next session on leaders and followers, then what are the synchronous, asynchronous application on it, and then how do we handle the failed replicas. Okay, so leaders and followers is a basic approach where it one is a leader, which is a right place where the right happens. Right now, I will not talk about write replicas. I'll only talk about the read replica, which is a follower. Follower can also be a write. Okay, write replica, which is a multi-leader, but we'll not talk about that. We are just talking about leader and follower with a single leader. Okay, so if you see in the diagram, so user updates the picture URL, okay, and it sends to the leader, and then data change is replicated to all the followers. And when user, some other user, which is 2345, it tries to read, it reads from the replica. Easy, right? There is no locking. I will not go to leader and read it, because there is a replica in place. I am reading directly from a replica. So this is the basic stuff of reader and followers, that leaders always take writes and followers always take the reads. Okay, in a single leader based approach. So when client wants to write to a database, they go directly and write to the leader, and the data is stored in their local storage, which is their disk. Okay, now this approach of leader follower can be again horizontal scaling, vertical scaling, anything. That again, this decision is dependent upon the scenario. So always in your interview questions you will get a scenario to answer it. If it is more read heavy, you will go with single leader and more replicas. If it is write heavy, you will go with multi leader. So we'll discuss all of that, but don't assume that there is a single answer to any question. There are many scenario based questions, and that is what is asked in your interviews. Whether you will increase the load horizontally, you will increase parallelly, sorry, vertically in which way. If there is a cost issues, you may not want to increase horizontally, you still keep everything there, then they will put more constraint on top of it. What will happen if your disk crashes, you cannot share the disk. So you'll have to talk about that perspective, that I'll keep replicating the data from the disk as and when I receive it. So how will you manage replication then? So this will evolve. Okay, so whenever you jump into it and you see that, okay, people are keep asking, drilling down, drilling down, drilling down, and until and unless they actually get your answer, they'll keep drilling down. If you say one thing wrong, they'll stop there. Okay, that you don't know what is scaling in all together. But eventually, when it comes to distributed databases, it is replication, partitioning, and sharding. So we have seen scaling, horizontal, vertical. We have discussed replication, why it happens, what it is. We have started discussing about synchronous, asynchronous, and leader and followers way of replication. So I would stop this recording. uh, we'll take questions if you have any.